Now there'll be some questions where you'll be given an expression which is a product of some linear factors, say x minus 1, x minus 2, x minus 3, and x minus n. Now when I'll multiply all these factors, I'll get a polynomial expression of degree n. Now in this expression, they'll ask you some specific terms. Maybe they'll ask you to find the coefficient of x to the power 0. I know that x to the power 0 is constant term. So when do I get a constant term? So when each of this constant term in each factor gets multiplied with the other constant terms. So minus 1 gets multiplied with minus 2 gets multiplied with minus 3, and in the end, it gets multiplied with minus n. So when all these constant terms, they are being multiplied, then I'll get a coefficient of x to the power 0. So in this case, if I find coefficient of x to the power 0, all I need to do is I need to multiply all these constant numbers. So it is minus 1 into minus 2 into minus 3 and then minus n. So it will be simply minus 1 to the power n into factorial n. So in this question, the coefficient of x to the power 0 is minus 1 to the power n into factorial n. Another question could be, find the coefficient of x in this expression. Now, when do I get a coefficient of x? So if any x gets multiplied with any other x, then it becomes x square or higher powers of x. So that means I'll just need one x, and that one x needs to be multiplied to a constant term from all other expressions. So that is, I have to take, so there are n factors. So from these n factors, I have to take n minus 1 factors at a time. And then I need to multiply these constant terms from these n minus 1 factors. And then all these constant terms, or this product of constant term, when it gets multiplied with x, then I'll get coefficient of x. So I can take first n minus 1 terms, then I can take n minus 2 terms, and then x minus n terms. So every time I need to leave a term. So every time when I leave a factor or an expression, then I'll get a new coefficient of x. So how do I get coefficient of x? So if I leave, suppose, x minus n. So when I multiply all the constant terms, I get minus 1, minus 2, minus 3 and minus n minus 1. So when it gets multiplied with x, I'll get a coefficient of x. So this is minus 1, minus 1, minus 1, n minus 1 times. So it is minus 1 to the power n minus 1. And then it will be 1 into 2 into 3 and n minus 1. Now here, for the sake of symmetry, what I'll do is I'll multiply it with n and I'll also divide it with n. Now it becomes factorial n. So this term is minus 1 to the power n minus 1 factorial n by n. So if I leave this term x minus n, then the coefficient of x will be minus 1 to the power n minus 1 factorial n upon n. Now what if I leave this factor n minus 1? Now in that case, coefficient of x will be minus 1, minus 2, minus 3, it will be minus n minus 2, and then it will be minus n. So that's the coefficient of x. Now again, what I do is, for the sake of symmetry, I'll multiply with n minus 1 and divide with n minus 1. So again, it will be minus 1 to the power n minus 1. It will be factorial n upon n minus 1. So if I leave this n, I get factorial n upon n. If I leave n minus 1, I'll get factorial n upon n minus 1. If I leave n minus 2, I'll get factorial n upon n minus 2. So if I'll do this for all the factors, then I can simply write coefficient of x in this case will be, so minus 1 to the power n minus 1 into factorial n. It appears in all the products. And then first one is 1 by n, and then it is 1 upon n minus 1, 1 upon n minus 2, and it will continue up to 1 upon 3 plus 1 upon 2 plus 1 upon 1. So that is the coefficient of x in this expression. Now let us take a recursive polynomial which is defined as p1x is x minus 2 square, p2x is x minus 2 whole square minus 2 whole square, p3 is x minus 2 whole square minus 2 square minus 2 whole square, and then in general pkx is pk minus 1 x minus 2 whole square. Now, how do we solve this question? Now, when it says, now there are 4 options and we have to find like which of these options are correct. Now, I'll start with the simplest one, which is I need to find the constant term. So, I'll try and find the constant term in each of the polynomial. So, it says in pkx, the constant term is 4. So, here I'll use mathematical induction. So, I'll assume that the constant term is 4. So, for n equals 1, So for n equals 1, I'll get p1x and it'll be simply x minus 2 square. So there'll be x square minus 4x and plus 4. So here indeed constant term is 4. So that is p1 is true. Now let it be true for n equals k. So I'll assume the constant term in pkx is 4. Now I have to prove it for n equals k plus 1. Now for n equals k plus 1, if I write p k plus 1x, I know that it is pkx and then minus 2 and then whole square. So I know that for this pkx, so it will be some polynomial function of x and then its constant term is simply 4 and then minus 2 whole square. So it will be fx and then plus 2 whole square. So it will be simply fx square and then plus 4. Now this fx, there is no constant term in fx. So this fx is clearly a function of x. So for pk plus 1x, the constant term again is simply 4. So that is option number A is correct. So in any of these polynomials p1, p2 and pkx, the constant term is simply 4. So it is independent of this value of n or k. Now we'll come to the second part, which is we need to find the coefficient of x. So either it is minus 4 to the power k or 4 to the power k. So what I'll do is I'll find it for n equals to 1. So for p1x, I'll write it as x minus 2 square, that is for n equals 1. So which is x square minus 4x and then plus 4. Now here the coefficient of x is minus 4. So it cannot be 4 to the power k. So it can be minus 4 to the power k. So I'll use induction using minus 4 to the power k. Now I'll let it be true for n equals k. So that is, so I'll assume for pkx, the coefficient of x will be, so it'll be some polynomial function fx for higher degree polynomial square and all the higher powers. And then I'll assume it is minus 4 to the power kx and we know that its constant term is simply 4. So for pkx, I'll expect pkx as fx minus 4 to the power kx and then plus 4. Now I have to find it for n equals k plus 1. Now for n equals k plus 1, so I'll write pk plus 1 as pkx minus 2 whole square. So I'll write it as fx minus 4 to the power kx plus 4 and then minus 2 whole square. So it will be fx minus 4 to the power kx and then plus 2 whole square. So when I'll square it, there will be lot many terms, but I need to find coefficient of x. I'll get coefficient of x when these two terms they get multiplied. So I'll get 2 times and then minus 4 to the power kx into 2. So there'll be minus 4 to the power k plus 1 into x. So that is for pk plus 1, the coefficient of x is minus 4 to the power k plus 1. So that is option number C is also correct. Now we'll come to the coefficient of x square. Again, we'll do it with induction. So for n equals 1, so that is p1x, so it will be x square minus 4x plus 4. So in this case, coefficient of x square is 1. So if I'll put k as 1, I'll get 4 minus 4 to the power 0 upon 3, which is 3 upon 3, which is 1. So that is, it is true for n equals 1. Now I'll assume that let it be true for n equals k. So that is, I'll say, so this pkx will be some function of fx and then what is the coefficient of x? Coefficient of x here is minus 4k and this is coefficient of x square. So I'll simply write plus 4 to the power 2k minus 1 into 4 to the power k minus 1 upon 3 into x square and then plus. So then it will be minus 4 to the power k x and then what is the constant term? Constant term is simply 4. So that's your pkx. Now I have to prove it for pk plus 1. So if I write pk plus 1, so it will be simply pkx minus 2 whole square. So there will be fx and then it will be 4 to the power 2k minus 1 minus 4 to the power k minus 1 upon 3 whole square, sorry, 3 into x square, then minus 4 to the power kx, and then plus 4, and then minus 2. So there will be plus 2 and whole square. Now from this expression, I need to find the coefficient of x square. Now how do I get the coefficient of x square? I'll get the coefficient of x square when this term, it gets multiplied with 2, and when I'll square this term. So the coefficient of x square will be, so there will be 2 times, and then this value, 4 to the power 2k minus 1 minus 4 to the power k minus 1 upon 3, and then into 2, and here it will be, so if I'll square it, I'll get 4 to the power k whole square. So that should be your coefficient of x square. So if I'll simplify, I can write it as, so this is 2 into 2 4, so I'll multiply this 4, so this is 4 to the power 2k, and then minus, there will be 4 to the power k upon 3, and then plus 4 to the power 2k. So if I'll add them, I'll get 4 into 4 to the power 2k minus 4 to the power k upon 3. So there will be 4 to the power 2k plus 1 minus 4 to the power k upon 3. So if I replace k with k plus 1, so there will be 2k plus 1, k and 3. So that's the same result. So that is pk plus 1 is true. So let us take up a question, and this question is, find the coefficient of x to the power 70 in the product x minus 1, x square minus 2, x cube minus 3, and x to the power 12 minus 12. Now what I'll do is, I'll try and find the highest term. So if I'll multiply all these x's, then what is the power of x that I'll get? So if I'll multiply everything, then I'll get x to the power 1 plus 2 plus 3 up to 12. So which is n into n plus 1 by 2. So there'll be x to the power 78. So when each of the x from each of the factor or each of the bracket gets multiplied, then I'll get the power of x as 78. But in this question, I'm not supposed to find the coefficient of x to the power 78 because there will be simply 1. I'm supposed to find coefficient of x to the power 70. So if I had to find coefficient of x to the power 70, then I have to multiply these x's in such a way that I get the sum of powers as 70, not 78. Now that means from this 78, which is x to the power 78, I have to leave out certain expressions in such a way. I have to leave out x to the power 8 so that it becomes x to the power 70. So I'll multiply all the terms except for the terms that will make the power of x as 8. So now what are the ways of doing it? So one of the way of doing it can be, if I multiply all these powers of x except x to the power 8 minus 8, in that case the product of all these x's will be x to the power 70 and then some other value, and then it will be x to the power 8 minus 8. Another way of doing it can be, if I'll take x to the power 7 minus 7 and I'll take x minus 1. So 7 into 1 is 8. So I'm leaving behind 8, and then here I'll have x to the power 70 minus something. So I need to find in how many ways can I express 8 as a sum of distinct numbers. So one of the way was simply 8. Another one was 7 plus 1. Other could be 6 plus 2, or it could be 5 plus 3, or 5 plus 2 plus 1, or it could be 4 plus 3 plus 1. So these are the 6 possibilities, and there will be no other possibility. So that is x to the power 70, 7 and 1. Next one will be x to the power 6 minus 6, x square minus 2. Fourth one will be x to the power 70, and then it will be x to the power 5 minus 5, x cube minus 3, x to the power 70, and then x to the power 5 minus 5, x square minus 2, and then x minus 1, and finally it will be x to the power 70, and then x to the power 4 minus 4, x to the power 3 minus 3, and x minus 1. Now when x to the power 70 gets multiplied with minus 8, I'll get x to the power 70. So one of the coefficient here is minus 8. Now when this x to the power 70 gets multiplied with this constant term, which is minus 7 into minus 1. Here it will be when x to the power 70 get multiplied with minus 6 and minus 2. So there will be minus 6 and minus 2. Here the possibility will be minus 5 and minus 3. Here x to the power 70 has to be multiplied with minus 5, minus 2, minus 1. Because that's the constant term, right? What we are doing is we are multiplying this x to the power 70 with a constant term in each of this expression. So that's how we are going to get the coefficient of x to the power 70. Now in this case it will be minus 4, minus 3 and minus 1. So which is simply minus 8 plus 7 plus 12 plus 15 minus 10 and minus 12. So in that case it will be, so 12 and 12 will cancel. So this is 15 plus 7, which is 22. 22 minus 18 is simply 4. So the coefficient of x to the power 70 in this product will be simply 4. Now the question is, in how many different ways we can buy an ice cream for 10 euros if we have 3 notes of 5 euros, 6 notes of 2 euros and 2 notes of 1 euro. And we'll also assume that each note for same denomination will be same. So these 3 notes, they are identical. These 6 notes, they are identical. And these 2 notes, they are identical. Now, if we look at these 3 notes of 5 euros, then the number of ways or the amount that I can pay using these 5 euro notes are, so either I'll pay nothing, which is x to the power 0, or I can pay 5 euro or 10 euros, or if I use all the 3 notes, I can spend 15 euros. Now, for this 2 euro notes, I'll write x to the power 0, x to the power 2, x to the power 4, and then if I'll spend all the 6, it'll be x to the power 12, and then for these 2 notes of 1 euro each, either I'll spend 0 or 1 euro or 2 euros. So this is how I can spend all these notes. Now we need to buy an ice cream for 10 euros. So that means from this series, I need to find coefficient of x to the power 10. So if I'll write it as, this is 1 plus x to the power 5 plus x to the power 10 plus x to the power 15, and here will be 1 plus x square plus x to the power 4, x to the power 6, x to the power 8, x to the power 10, x to the power 11, 12, and then here it is 1 plus x square. Now I'll ignore all the terms which are greater than x to the power 10 because I need to find coefficient of x to the power 10. So I'll ignore this x to the power 15. I ignore this x to the power 12. So I'll write it as 1 plus x to the power 5 plus x to the power 10, and here will be 1 plus x square plus x to the power 4, x to the power 6, x to the power 8 into x to the power 10, and this is 1 plus x square. Now I'll start multiplying these two series. So if I'll multiply them, I can write 1 plus x square plus x to the power 4 plus x to the power 6 plus x to the power 8 plus x to the power 10. Now I'll multiply this x to the power 5. So I'll get x to the power 5, x to the power 7, x to the power 9. Now hereafter, power of x will be greater than 10. So I'll discard it. Now with x to the power 10, I'll get only 1, which is x to the power 10, and this is 1 plus x square. So if I'll write it as 1 plus, and then we have this x square, then we have x to the power 4, then it will be x to the power 5, then we have x to the power 6 plus x to the power 7 plus x to the power 8 plus x to the power 9, and then plus 2 into x to the power 10, and this is 1 plus x square. Now I'll multiply this series with this given series with the view that I need to find coefficient of x to the power 10. Now when do I get coefficient of x to the power 10? I'll get coefficient of x to the power 10 when x to the power 8 get multiplied with x square, when x to the power 9 gets multiplied with x, and when 2x to the power 10 gets multiplied with 1. So x to the power 8 into x square. So there will be 1 into x to the power 8 into x square plus now 1 into x to the power 9 into x, and then 2 into x to the power 10 into 1. So it will be 4 into x to the power 10. So here the coefficient of x to the power 10 is simply 4. So in how many different ways? So there will be only 4 different ways in which we can buy this ice cream for 10 euros using these notes. Now another method of solving the same question can be, if I have to spend 10 euros, then it can be 5x plus 2y plus z, and this value, it should be 10. So where x is less than equal to 3, because there are 3 nodes, y is less than equal to 6, and z is less than equal to 2. Now we'll consider the first case. Now case 1, when the value of x is 0. So now we have not spent any 5 euro notes. So I'll get this equation as 2y plus z equals to 10. Now we know that this y, it is multiplied with 2, right? So y is an integer only when this 10 minus z, it is an even number. So that means I can choose only even values for z. So I can choose z as 0 or z as 2. So if I'll put z as 0, I'll get y as 5. And if I'll put z as 2, I'll get y as 4. So I get 2 solutions. One solution is 0, 5, 0, and the other solution is 0, 4, and 2. Now case 2, when the value of x is 1. So if the value of x is 1, so here I'll put 5. So it'll be 2y plus z, and this should be 5. Now in this case, z should be an odd number. So there is only one possibility. So value of z is 1. So if I'll put z as 1, I'll get value of y as 2. So then in this case, there is only one solution, in which is 1, 2, and 1. And this third case, if I'll take x as 2, I'll get this as 2y plus z equals to 0. So which leaves us with only one possibility, and that is y should be 0 and z should be 0. So here will be 2, 0, 0. So there are only 4 cases possible. So number of different ways in which we can buy this ice cream is simply 4, which are represented by these 4 solutions of this equation.